In this video, we're going to look at our other two Riemann sum methods, as the midpoint and trapezoidal Riemann sums. Alright, so we previously learned how to approximate areas using Riemann sums, and we used the left or the right of an interval to make these approximations. And now we're going to find out two more. And the third method is going to be called the midpoint method. So if we have this interval, instead of using the left or the right, we're going to use the midpoint of each interval to determine our height. It's basically the same as the left and right hand sum, but you just use the midpoint of the interval. So it's kind of one extra calculation you have to do. All right, so how do you find the midpoint? Midpoints are just the average of two numbers. So add up the two numbers, divide them, or just know what the middle of two numbers is. All right, so we're going to approximate this using 4 subintervals, and we're doing from 0 to 8. So our interval is length 8. We have 4 intervals, they're each width 2. So I think about my number line. Start at 0, width 2, go another 2, go another 2, and go another 2. So these are my intervals. And what are the values I'm actually going to plug in to my expression? I'm going to do the midpoint. So between 0 and 1, or sorry, 0 and 2 is 1. Between 2 and 4 is 3, 5, 7. All right, so now when I go to find my Riemann sum, my first rectangle has a width of 2. And to find the height of it, I take my midpoint and plug it in 1 squared minus 1. My second rectangle has a width of 2. And I plug the midpoint of that interval, which is 3, into my function. And you see the process, 2. The midpoint of the next interval is 5, so I'm going to plug 5 in. Plus the width is 2. I'm plugging 8 in. No, I'm not plugging 8 in. 8 would be a right-hand sum. I'm doing a midpoint sum, so I'm going to plug in 7. This is 2 times 0. This is 2 times 6. 2 times 20. And 2 times 42. Right. So 12, 40, 84. 52 and 84. 136. So that's a estimate using the midpoint sum. So you see it's basically the same process we were doing with left and right hand sums, just one extra calculation of once you have your intervals, you have to pick out the midpoint for each one as well. So the final method we're going to use is the trapezoidal method. So what's that going to look like? Let's just break this up into 4 equal pieces. And then for each interval, I'm going to draw my line, the height of my function. And before I would use like the left-hand side. So if I was doing a left-hand sum, I would like draw this line across. But I'm not doing a left-hand sum. If I was doing right-hand sum, I would go here and draw this line across, but I'm not doing right-hand sum. So how do you do a trapezoidal sum? Trapezoidal sum, what you do is you basically draw a diagonal line that connects those two ends. And you can see right away, I'm only on 4 subintervals, but a trapezoidal sum is actually a pretty good estimation because I barely have any extra spots or stuff that I'm missing in this trapezoidal sum. But it's not a rectangle, so it's a little bit harder to figure out. So how do you find the area of a trapezoid? It looks like this. You have base times your heights. And basically the idea is when you have this trapezoid, if you average out the two heights, so you kind of hit the middle of the two heights, it's the same as that rectangle. All right, so really you're just kind of averaging out the heights that you have on the left and right, and that gives you the height of that you're plugging into the formula. All right, so let's find the area of this trapezoid using the trapezoidal rule in 4 subintervals. Right, so width of 4 subintervals, each one has a width of 1. All right. So for my trapezoidal rule, I like to plug in the values first. So I plug in 0, that's going to be a height of -1. I plug in 1, that's going to be a height of 2. Plug in 2, 6 minus 1 is 5. Plug in 3, that's 8. Plug in 4, 12 minus 1 is 11. Okay. So now my trapezoidal rule is going to be this trapezoid, that trapezoid, that trapezoid, and that trapezoid. All right, so what is the answer going to be? My first area is width 1, and the height is the average of those two. Area 2, width 1, height is the average those two. Area 3, width 1, average of the two sides. And area 4, width 1, average of the two sides. -1 plus 1, this is just 1/2. This is 7/2, which is 3.5. 13/2 is 6.5. 19/2 is 9.5. So we add up all these together. We got 2 plus 3 and 6 is 9 plus 9 is 20. All right, so at the end, it's just a bunch of arithmetic figuring out the answer, but you can see the basic idea of the trapezoidal rule here. Widths aren't going to change, but for each individual stage, you're averaging the left and right of your interval. All right, to figure out what the height kind of is your trapezoid. There's another method that's using the trapezoidal rule. It ends up being, because you're just averaging all these things, and it's just being the average of your left-hand sum and your right-hand sum. So it's whichever method you prefer. You can either do a full left-hand sum and a full right-hand sum and average those two answers, and that's the same as the trapezoidal sum. So it's really depending on the problem and the person based on which one you think might be quicker. But there's just another way of looking at a trapezoidal sum. It's just averaging the two other sums. All right, so here's one for you to try on your own. I try a trapezoidal rule and 3 intervals to approximate this area. I'll show you the answer in 3, 2, 1. And this is the final answer I came up with, 220.5. All right, each trapezoid has a width of 3, so make sure you don't put 1s there, because this one actually have a width of 3. And just averaging the values on the left and right when I plug those into my function to figure out my trapezoidal approximation. As a quick recap, you can use the midpoint of an interval for a Riemann sum. It's called a midpoint sum. The trapezoidal rule is the only rule that doesn't use rectangles, but the formula is kind of simple. It's base times height, but the height is like the average of the two heights. And you can also just average a left and right hand sum to get a trapezoidal sum instead of doing trapezoids. That's just an extra thing you can remember to avoid doing trapezoids at all.